Okay, let's unpack this. We've got a ton of source material here covering the semiconductor industry. We're really zeroing in on the key news and developments from the week of June 7th through June 14th, 2025.
Right.
It's a fascinating moment in this space, isn't it? You look at the market data, you see some, well, seemingly mixed signals coming out of Q1,
Mhm.
but then you also see these strong undercurrents that point directly towards future growth. My background, in semiconductors and finance, it gives me a particular lens on this stuff. I'm always looking for what truly impacts the business and the investment landscape.
It really is fascinating because,
Yeah.
like you said, on the surface, you might see a slight dip somewhere and wonder.
Yeah.
But when you dig just a little deeper, you start to see where the energy and, frankly, where the money is actually moving. And the picture becomes much clearer.
So our mission today really is to take this stack of sources, things like Dr. Pry's weekly review, various reports, articles, and just distill the most important market data, the critical technology trends, those signals from investment and M&A.
Right. And, of course, the global policy developments from this past week. We want to connect the dots for you, whether you're navigating this industry professionally or maybe looking at it from an investment perspective.
Exactly. It's about understanding the interplay, you know, between all these different forces. The market numbers, they tell you where we've been, maybe,
Mhm.
but the technology and the policy news, that tells you where we're likely headed.
All right, let's dive right in then. Market performance snapshot, starting with the global foundry market, Q1 2025. According to the numbers in these sources, revenue came in at what, $36.4 billion?
That's the number. And that represented a 5.4% sequential decrease compared to Q4 of 2024.
Okay.
Now, that number, on its own, you might think, okay, straightforward seasonal slowdown. Q1 often sees a dip after the busy holiday electronics buildup.
But the sources point out it wasn't just business as usual seasonality, right? There were other factors that actually cushioned that expected drop. Precisely. And this is where it gets interesting, I think. There were a couple of key external factors providing some, well, unexpected lift.
Okay.
One was the anticipation of new U.S. tariff policies. Apparently, some clients pulled forward orders to get ahead of potential deadlines.
Ah, okay. Created a bit of a surge.
A temporary surge, yeah. And the other significant factor was the continuation of China's old-for-new consumer subsidy policy. Remember that started back in 2024?
Right, right.
That policy continued to stimulate domestic demand, particularly for consumer electronics, which, of course, use a lot of chips.
That's a crucial insight for you listening. It tells you that even when you're facing natural market cycles, these geopolitical forces, government policies, they can introduce significant, if sometimes temporary, demand drivers. So understanding these offsetting factors is really key to interpreting those Q1 numbers accurately.
And that naturally leads us to the Q2 2025 outlook, which actually paints a more optimistic picture based on these reports.
It does. The expectation is for sequential revenue growth, pretty much across the board for the top 10 foundries in Q2.
Yeah, and the anticipated drivers for this growth, they seem more tied to underlying market momentum this time, that China subsidy policy, expected to maintain some of its impact.
Okay.
We're also entering that period of preparation and stocking for the new smartphone launches that typically happen in the second half of the year.
Right, the H2 ramp.
Exactly. That creates significant demand in the preceding quarter. And maybe most importantly, demand from AI high-performance computing, AI HPC, that just remains consistently stable and frankly robust.
So the Q2 story, it seems to shift a bit. It's less heavily influenced by those maybe one-off policy effects
Right.
and more driven by the recurring smartphone cycle and that sustained structural demand from the AI infrastructure build-out.
Right.
These are the segments and timelines where you should probably expect to see the market's energy concentrated next.
And just to connect this to the broader industry health,
Yeah.
if you look upstream at the IC design market,
Mm.
while Foundry saw that Q1 dip,
Yeah.
the IC design side actually hit a new record.
That's right. Global IC design revenue, Q1 2025, $77 billion. That's a 6% sequential increase. A record quarter for chip designers.
This disparity is pretty telling, isn't it? It
Huh.
shows really strong demand upstream, right at the design stage.
Mm-hmm.
The primary drivers noted for this record growth, well, again, that continued early stocking ahead of U.S. tariffs that affected designers placing orders for, new tape-outs or test chips.
Okay.
And again, the relentless ongoing construction of AI data centers globally.
This gives you, the listener, a different perspective. Even if foundry wafer shipments for some segments saw that seasonal dip, the fundamental demand for new chip designs and just the sheer volume of AI infrastructure build-out kept the design houses humming at record levels.
Yeah.
The AI boom isn't just about buying current chips, it's driving massive investment and activity right at the foundational design level.
Absolutely. Now, let's take those Q1 foundry market dynamics and maybe see how they specifically impacted the key players.
Okay, let's start with TSMC. Still the undisputed leader, right? 67.6% market share, $25.5 billion in revenue. They saw that 5% sequential decrease we mentioned, kind of aligning with the overall market dip.
But interestingly, their Q1 probably could have been worse without some key demand drivers. The sources point out that strong AI HPC demand was a major mitigator for them. Also, those tariff hedge orders, the source, specifically mentioned TV chips that helped counter the usual seasonal dip in smartphone-related wafer shipments. So AI is really a bedrock for TSMC right now.
Okay, now compare that to Samsung Foundry. Number 2, 7.7% market share, $2.89 billion revenue. They experienced a larger sequential decrease, 11.3%.
Yeah, a bigger dip. The sources attribute this mainly to two things. First, those U.S. advanced process restrictions apparently limited their ability to produce cutting-edge chips for some Chinese clients.
I see.
And second, their specific customer base and product mix, it just didn't benefit as much from China's consumer subsidy program compared to some of their competitors.
That really highlights how geopolitics in your specific customer portfolio can lead to very different outcomes, even within the same market, doesn't it?
It really does. And here's where we see maybe a direct beneficiary of those offsetting factors. SMIC, ranked number 3. They actually saw positive growth. Revenue at $2.25 billion, up 1.8% sequentially.
Wow, positive growth in Q1, that's notable. The sources indicate SMIC directly benefited from clients stocking up ahead of U.S. tariffs and also saw orders pulled in early because of the China consumer subsidies. These tailwinds were strong enough to overcome any negative trends they might have faced in average selling prices, ASPs.
Yeah, SEM6 performance is a really clear example of how those specific policy-driven demand bursts translated into tangible revenue growth for certain players, positioned to capture it.
Okay, moving down the list. UMC remained at number 4, $1.76 billion revenue, down 5.8% sequentially. For them, it looks like client pre-stocking did help offset some seasonality, kept wafer shipments, factory utilization relatively stable, but their ASP saw a decline due to an annual adjustment.
In global foundries, $1.58 billion saw a larger drop, down 13.9% sequentially. The sources note their customer base is primarily outside of China, meaning they didn't really get any lift from that China subsidy program. So that just compounded the effect of seasonality hitting both their wafer shipments and their average selling price.
Huahong Group ranked 6th, $1.01 billion group revenue, down 3% sequentially. Looks like within the group, H.H. Grace benefited from new capacity coming online and maybe a low-price strategy.
Yeah, trying to push shipments.
But overall group revenue still saw that slight dip.
And Vanguard, they actually saw an increase in utilization and moved up to 7th place. The sources directly link their increased utilization to that client pre-stocking activity, anticipating the tariffs.
These granular details for each foundry, they really illustrate the point. Macro factors like tariffs, subsidies, geopolitical restrictions, and where a company is positioned within key segments like AI, HPC, or consumer electronics, it's all having very distinct impacts on individual company performance. It's far from a uniform market experience.
Absolutely. Couldn't agree more. Now, maybe we should shift gears a bit. Move from the market numbers to the underlying technological forces that are, sculpting the industry's future.
Good idea.
And right now, it feels like almost everything starts with AI and high-performance computing.
It's absolutely the dominant narrative, isn't it? And this week's news just confirms that with some really concrete developments. AMD, for example, they launched their MI350 series GPUs, claiming a dramatic 35x faster inferencing capability compared to their previous gen.
Wow, 35x. That kind of performance jump, it's not just a number, right? It fundamentally changes what types of real-time AI applications become feasible, especially at the edge or maybe in smaller data centers. It expands the market beyond just the hyperscalers. And memory is so critical for feeding these processors. Micron is now shipping samples of their HBM4 memory 36 GB, 12 high stacks, specifically targeting the data center. and cloud AI markets, where that high bandwidth is just paramount.
And NVIDIA, they just keep pushing their strategic build-out.
Yeah.
They announced significant deployments of their Blackwell AI infrastructure over in the EU, aiming for over 3,000 exaflops of AI compute power for sovereign AI initiatives.
Yeah, massive numbers. And they're also launching an industrial AI cloud initiative, partnering with the major players like Ansys, Cadence, Siemens, basically bringing powerful AI acceleration directly into manufacturing applications.
So beyond just faster chips, we're seeing a major focus on how AI chips are designed and architected, right? The sources mentioned agentic AI and chip design as a key focus area.
That's right, agentic AI. That's essentially using AI itself to automate and optimize the incredibly complex process of designing semiconductor chips.
Which could drastically speed up development cycles, I imagine.
Potentially, yeah. We also saw AMD acquire the team from Untether AI. They're known for their at-memory compute architecture.
Okay, at-memory compute. Can you quickly explain what that refers to?
Sure. So traditional computing, involves moving data back and forth between the processor and separate memory chips. Lots of movement.
Right, the von Neumann bottleneck.
Exactly. At-memory compute, or near-memory compute, attempts to perform computations within or right next to the memory units themselves. The whole idea is to drastically reduce the time and, importantly, the energy spent moving data, which is a major bottleneck for AI workloads that process just huge data sets.
That makes a lot of sense. And the sources emphasize the critical role of memory innovations, things like LPDDR6, TIM, processing in memory, another way to bring compute closer to data, wide I/O for high bandwidth connections, and advanced packaging techniques for truly achieving full agentic AI capabilities, especially on power-constrained devices like smartphones.
Yeah, you need all those pieces. And we're even seeing completely different computing paradigms gaining traction. VectorWave raised funding for their analog computing architecture.
Analog.
Yeah, it's a different approach than traditional digital chips, performing AI inference directly on raw RF signals without first digitizing them.
Interesting.
And showing the global push here, the Chinese Academy of Sciences unveiled what they claim is a fully automated processor chip design system. Said it could accelerate development, maybe reduce reliance on human designers for certain tasks.
And new AI applications are constantly emerging. Qualcomm demonstrated a standalone generative AI assistant running on smart glasses using their Snapdragon AR1 Plus platform,
Wow.
putting powerful AI directly on wearable devices. Plus, Sandia and SpinCloud deployed a large-scale neuromorphic system, Spinnaker 2, for critical missions. Neuromorphic chips, those are designed to mimic the structure and function of the human brain, right?
That's the idea, yeah. Trying to compute more like a biological brain. So this whole section paints a picture of just incredible innovation velocity in AI, not just incremental improvements, but fundamental shifts in architecture, design methodology, application areas.
Yeah.
It really shows you where the R&D investment is concentrated for the next wave.
Okay, so moving beyond the immediate AI boom, quantum computing. It continues its march forward, although maybe on a longer timeline.
Yes, definitely a longer game. But key milestones are being set. IBM laid out their roadmap, aiming for something called quantum Starling by 2029.
Okay.
The target there is significant. 200 logical qubits, that's error-corrected qubits, which are much more stable and reliable than the raw physical qubits researchers often start with. They're aiming to handle 100 million gates. Achieving logical qubits is a really key step towards fault-tolerant quantum computing.
And we saw a major strategic move, IonQ acquiring Oxford Ionics for what, a staggering $1.075 billion, mostly in stock.
Huge deal. Oxford Ionics is recognized for their method of integrating ion trap qubit technology directly onto standard silicon manufacturing processes.
So easier integration down the line.
That's the bet. That acquisition is a big vote of confidence in the ion trap approach, and it shows consolidation is happening as companies try to accelerate the path to practical quantum computers. There's also foundational research progressing, like Argonne National Lab's new method for controlling the collective magnetic properties of atoms, potential for building future quantum systems there.
These developments, plus things like Rigetti Computing's $350 million equity offering mentioned in the sources, it feels like quantum computing is actively transitioning, moving from purely theoretical research towards engineering, integration, building actual, albeit early, commercial systems.
Absolutely. That's where the serious investment is starting to flow now.
Okay, next up, let's talk about the fundamental enablers. New materials and processes, often less visible maybe, but absolutely critical for pushing performance boundaries.
Couldn't agree more. They're foundational. And the sources consistently highlight the importance of material science. We saw the launch of that joint lab between TSMC and the University of Tokyo,
Right, in Japan.
specifically focused on materials and processes, with an emphasis on practical applications for manufacturing. And the CSIS testimony also underscored the need for the U.S. to maintain its edge in material science, seen as a strategic priority.
And it's great to see recognition for the individuals driving this. DuPont scientists and engineers were honored as heroes of chemistry for their vital contributions to lithography progress.
Yeah, lithography is so key. That's the process of printing circuit patterns onto wafers, and it relies so heavily on advanced materials like photoresist.
And we're seeing specific material applications delivering real performance gains too. IMEC demonstrated a gallium nitride on silicon, or GaN on Si, E-mode MOSFET achieving record performance levels. That's crucial for developing high-power amplifiers needed for, say, next-generation 6G wireless communication.
Exactly. And Galaxy Semiconductors won an award for their gallium oxide semiconductor technology.
Yeah.
That shows immense potential for demanding applications. Think power electronics in space, aviation, high-speed EV charging, mainly due to its ability to handle really high voltages and temperatures.
So materials like GaN and gallium oxide are literally enabling new application areas for semis where traditional silicon might struggle, particularly in harsh environments or high-frequency domains.
Precisely. We also saw IMEC discuss advancements in process techniques, like their forksheet FET architecture. That uses novel material configurations to extend gate-all-around transistors, which are the next generation after FinFETs,
Right.
down to the A10 node, pushing density even further.
Okay, so as processors get faster and AI demands more data, moving that data becomes the next bottleneck, right? Which makes developments in high-speed connectivity standards and technologies absolutely critical.
Oh, hugely critical. And a major piece of news this week was the final release of the PCIe 7.0 specification.
PCI Express 7.0.
Yep. This standard, used to connect components inside a computer, delivers a massive performance leap. A raw bit rate of 128 gigatransfers per second, GTs.
Wow.
For context, that enables up to 512 gigabytes per second of bidirectional data transfer over a standard by 16 connection.
That's incredibly fast. And the sources noted some key tech enablers for this speed bump, like PM4 signaling,
Right, pulse amplitude modulation 4.
which transmits twice as much data per clock cycle compared to older methods, and something called flip-based encoding. What's also significant is the inclusion of support for implementing PCIe over optical fiber using retimers, essential for longer distances within massive data centers.
Absolutely. And industry players like Cadence, Synopsys, Alphawave Semi, they're already announcing products compliant with the new spec. They move fast.
They have to. We also saw the Ultra Ethernet Consortium, UEC, publish its 1.0 specification.
Right. That's an open Ethernet-based communication standard specifically designed for the unique demands of AI and HPC workloads, really focusing on optimizing bandwidth, latency, and stability.
And pushing the envelope even further, researchers at MIT developed a photonic processor for 6G signal processing, claiming it's 100 times faster than the best digital equivalent for certain tasks,
Wow. And
achieving 95% accuracy using deep learning. This shows optics and specialized architectures are really key for the extreme speeds needed in future communication.
These standards and technologies, they are the vital plumbing of the digital world, aren't they? Without faster ways to move data, the performance of even most powerful processors gets limited. They're enabling the AI revolution and future connectivity.
So true. Okay, another critical area. As semiconductors become embedded in literally everything, critical infrastructure, medical devices, vehicles operating in harsh environments, reliability and security move from being, desirable features to absolute core requirements.
That's a significant and growing challenge, absolutely. The sources highlight the increasing complexity in industries like automotive. Think about ensuring systems with thousands of ICs function perfectly for the vehicle's entire lifetime. It's becoming incredibly difficult. And as chips move into more extreme conditions, space, high-temperature engine compartments, industrial settings, ensuring reliability just takes on new dimensions.
And on the security front, guidance from bodies like NIST is crucial. This week saw mentions of their metrics for hardware security constructs and their framework offering, like 19 ways to build robust zero-trust architectures.
Right, zero trust where trust is never assumed, verification needed at every step.
Exactly. And the industry is responding with investment and innovation. Infineon hit a major milestone, shipping over 10 billion security controllers featuring their Integrity Guard architecture, designed to protect sensitive data and operations.
10 billion, that's a huge number. And Zero ISC received $10 million in funding to promote open-source silicon initiatives, aimed at building security into devices from the ground up, promoting transparency and trust.
So for you listening, this means reliability and security are no longer afterthoughts. They are fundamental design challenges with significant market implications, driving demand for specialized chips, verified design processes, the whole ecosystem.
Absolutely. Okay, shifting gears again, let's look at the macro environment. How policy, global competition, investment, how that's shaping the industry landscape.
Especially in the United States, where the GPS and Science Act aims to revitalize domestic manufacturing. But the sources reveal some significant on-the-ground challenges that are leading to some frustrating project delays.
Yes, the not in my backyard or NIMBY effect is cited as a real factor. Resident protests, often focused on concerns like water usage or increased traffic, they're causing roadblocks for planned facilities. The source mentioned the situation with Amcor's advanced packaging plant in Arizona.
Right. And environmental reviews are proving lengthy and, well, unpredictable. Micron's plans for that massive DRAM production base in New York, their environmental review has been postponed indefinitely, pushing back the original start date.
Yeah, indefinitely is a scary word in project management. And permitting processes are also a bottleneck. Even when projects like SK Hynix's HBM facility in Indiana eventually get approved, apparently they require lengthy negotiations with local governments, adding significant time to the schedule.
And the economic impact of these delays is just staggering. The sources put a number on it. They estimate a typical $20 billion fab project faces delay costs at around $5 million per day.
Per day. That quantification really brings home the urgency, doesn't it?
It does.
So, what are the potential solutions being explored? Well, some state governments are looking at proactive approaches. Things like designating pre-approved industrial sites with utilities and environmental permits may be already cleared. The explicit goal is just to accelerate that approval process.
The sources emphasize that permitting speed has become a critical factor in global semiconductor manufacturing competitiveness. It's no longer just about having the technology or the capital. It's about the ability to actually build the fabs quickly and efficiently, which requires navigating these complex regulatory and community engagement landscapes. There's a real need to build community trust and improve regulatory efficiency, it seems.
Yeah, it's a multifaceted challenge. But despite these hurdles, major U.S. investments are still proceeding. Micron significantly expanded its total U.S. investment plan to $200 billion. That's $150 billion for manufacturing, $50 billion for R&D. That's $30 billion more than previous announcements.
Wow. And Amazon is making massive investments in cloud and AI infrastructure. Pennsylvania, North Carolina, billions poured into the demand side of the equation, which ultimately drives the need for these advanced manufacturing facilities.
Absolutely. Policy recommendations are also evolving. The IDIF think tank is calling for renewing and extending manufacturing tax credits to include IC design activities, recognizing the importance of upstream innovation. CSIS continues to emphasize the strategic necessity of maintaining the U.S. edge in chip design and material science. And NatCast is actively working on workforce development through initiatives like the NSTC Workforce Awards Program, trying to help close the skills gap needed for all these new fabs.
So the picture in the U.S. is one of, well, ambitious policy and enormous capital commitment, but running into significant practical challenges on the ground: infrastructure build-out, regulation, community acceptance.
Yeah.
For you listening, this highlights both the opportunities and the friction points in the push for domestic supply chain resilience. It definitely impacts investment timelines and strategy.
And it's important to remember, of course, that other regions aren't standing still. They are actively investing to enhance their own semiconductor ecosystems.
Right. In Asia, we saw that TSMC and University of Tokyo joint lab launch in Japan, focusing on materials and processes for practical applications.
In Europe, collaborative projects like the 58-partner Genesis project are addressing sustainable supply chains. And the FAME's pilot line is focused on developing the skilled workforce needed for advanced technologies like FDSOI.
FDSOI, fully depleted silicon on insulator.
Exactly. The UK also announced significant funding for a new supercomputer up in Scotland.
So these examples just show that countries and regions globally are making strategic investments, R&D, sustainability, workforce training, computing infrastructure, all to strengthen their positions in the global semiconductor competitive landscape.
Definitely a global race. Okay, finally, let's look at the markets and money dynamics. The M&A, the funding, market forecasts tells us where private capital sees the opportunities.
We saw several notable acquisitions this week. IonQ acquiring Oxford Ionics for over $1 billion, boosting their quantum qubit tech. Micronic acquiring Surfix Technologies for their plasma cleaning solutions used in advanced packaging.
Important.
And AMD acquiring the Untether AI team for their at-memory compute architecture. CoreWeave also struck a significant compute capacity deal with Google, which will then be resold to OpenAI.
These deals really show investment flowing into key future technologies, right? Quantum essential process steps like packaging, innovative AI architectures, and that CoreWeave Google OpenAI deal just underscores the immense ongoing demand for raw AI compute power.
Absolutely. And we saw a range of funding rounds across different areas, too, indicating pretty diverse investment interests. Multiverse Computing raised $215 million for LLM compression technology. CNX Semiconductor got $5.5 million seed funding to focus on recreating legacy chips.
Interesting. Legacy chips still needed.
Rigetti Computing completed that $350 million equity offering for quantum computing development. Volantis raised $9 million for its photonic compute platform. VLC Photonics received a $4 million grant for photonic IC design and test. And VectorWave raised $2.5 million for their analog compute architecture.
That mix of funding is fascinating, isn't it? It ranges from cutting-edge AI and quantum all the way to the essential, but maybe less glamorous world of legacy chips. And includes investment in entirely different computing paradigms, like photonic and analog. It reflects both the future bets and the need for essential components today.
We also got a specific market forecast data point from TechSet, predicting nearly 6% growth in mechanical planarization, or CMP, consumables revenue in 2025, reaching $3.6 billion.
Right, CMP. Critical step in wafer manufacturing, used to polish the wafer surface precisely between layers. So a forecast for growth in CMP consumables is a pretty direct indicator of expected increasing activity levels on the fab floor. More wafers being processed.
Makes sense. Okay, before we wrap up this deep dive, the sources also mentioned a few notable people in the news this week.
Yes, T.C. Chen was elected to the National Academy of Engineering for his pioneering work in IBM lithography. Very important figure.
Indeed. And sadly, Bill Atkinson, a true Macintosh pioneer, passed away.
Yeah, a legend.
And on a positive note, that group of DuPont scientists and engineers were deservedly recognized as heroes of chemistry for their significant contributions to lithography progress.
Great to see that recognition.
It's always important to remember the brilliant individuals who drive this progress. So to kind of recap this week's deep dive, we saw a market navigating Q1 dips, influenced by seasonality, but, notably cushioned by external factors like tariffs and subsidies, with a clearer path to growth anticipated in Q2, driven by those continuing subsidies, the upcoming smartphone cycle, and the enduring strength of AI demand. We explored the incredible pace of technological innovation, AI hardware, novel architectures, quantum advancements, new materials enabling performance leaps, critical progress in high-speed data transfer.
A lot of tech movement.
And we looked at the complex global landscape, highlighting those significant friction points and challenges in the U.S. push for manufacturing capacity despite ambitious goals alongside strategic investments happening elsewhere. The M&A and funding activity just reinforces that private capital is placing bets on these key future technologies and also enduring demands.
It truly is an industry being shaped simultaneously by fundamental technology pushes, shifting market forces, and significant geopolitical and policy interventions. A complex mix.
Absolutely. So here's maybe a final thought for you to consider as you process all of this information. We're seeing the pace of technological development accelerate so rapidly, aren't we? New standards ratified faster, chips getting exponentially more powerful, breakthroughs in AI and quantum announced regularly. How does that breakneck speed of innovation contrast with the much slower, more complex, and often more contentious challenges of building the necessary physical foundation required to deploy that technology at scale? Things like constructing fabs, upgrading power grids, navigating environmental reviews, gaining community acceptance. Is the pace of our technological potential maybe outstripping our ability to build the physical infrastructure needed to actually realize it?
That's a great question. The friction between the digital speed and the physical speed.
Or maybe think about the diverse set of computing paradigms we discuss: analog, photonic, neuromorphic, alongside traditional digital scaling. What does this suggest about the future architecture of computing? And what implications does that have for where investment will flow and, crucially, the types of talent the industry will need in the years to come?
It certainly points towards a future where the computing landscape might be much more varied and specialized than it is today, less monolithic.
Lots to think about from just one week of news. We hope this deep dive has given you some valuable insights into the key developments shaping the semiconductor industry right now. Keep exploring these fascinating topics.